In lesson 5, we're going to be taking a look at squares and circles and how distributive property can relate to the equations of circles. So let's take a look and just distribute these mentally. Okay, these are on page 39 in your workbook. I'm going to release them on the screen, show you one at a time, but just mentally think about distributing. So you don't have to write it down. You don't have to do any of this, but just think about how you would do it. So distributing, if you remember, means taking this 5 and it's times the x plus 3. So we're distributing that 5, which means giving it or multiplying it to each of the pieces in the parentheses. So we'd be doing 5 times the x and 5 times the 3. So 5x plus 15. So this one we would be giving the x to each piece in the parenthesis with multiplication. So multiplying the x times the x being x squared and the x times the negative 3, which would be negative 3x. Now we're going to be distributing 2 pieces. So now we, instead of just having one thing to distribute, okay, where here we only had the 5 to distribute, here we only had the x to distribute. Now we have 2 things to distribute. So we're going to distribute the x to both pieces and the 4. So we'd be doing x times x. We'd be doing x times 2. Then we would need to distribute the 4. 4 times the x, 4 times the 2. So you'd have a lot of pieces here. So x times x would be x squared, and I'll write this one out for you, but x times x, so you'd get x squared for that. X times 2, so you'd get plus 2x for that one. Then distributing the 4, so you'd be multiplying the 4 times the x, so that'd be a positive 4x. And then multiplying the 4 and the 2 and getting 8. But so you distribute each of those in. And now you could put these together because they're like terms. So you'd end up with x squared plus 6x plus 8. Okay, so then in this one, again, we'd also be doing that. We'd be taking the x to both terms. So x times x times negative 5. So we'd be doing the x times the x. We'd be doing the x times the negative 5. Okay, distributing this part. Then we'd also be distributing in the negative 5. So we'd be doing negative 5 times x, and we'd be doing negative 5 times negative 5. So that's kind of what you're doing mentally. And then we would get x squared minus 5x plus 25 and could simplify. But we're just thinking about distributing mentally here. So you don't need to have written that down, but just think about what you're doing. All right, so now let's actually do this, okay, on page 40. So now we'll actually write out distributing these and coming up with each expression. So we want to be distributing the x and the negative 7 in here. And then I'll help you just kind of take a look at this one. What does squared mean? So remember that squared means something times itself. So what would this look like if we wrote it out? We would be taking x plus 4 times itself. Then it looks more like what we just talked about. So go ahead, try these 4 expressions, and then come back to the video. All right, so we are going to work on distributing these out. So hopefully you felt okay about that. So we're going to take this x and multiply it into both these terms. We're going to do x times x, which is x squared. We're going to do x times the negative 7, which is negative 7x. Then we're going to distribute the negative 7 to both pieces. So negative 7 times x is negative 7x. And -7 times -7 is positive 49. And then we'll combine some like terms here to simplify. So we see that these terms we could combine. So we'll get x squared -7x plus -7x is -14x. And then we have plus 49. Okay, for A. For part B, so we will again take the x and multiply it into both. So we're going to get x times x is x squared. X times the 4 is 4x. Then multiply the 4 in. Okay, so now multiply the 4 to both pieces. So 4 times x is 4x. 4 times 4 is 16. Combine your like terms there. Okay, so combine these and we get x squared plus 8x plus 16 for that one. Next one, so x minus 10 squared. So again, that's going to be x minus 10 times itself. And we'll take and distribute the x into both pieces. So x times x is x squared. X times -10 is -10x. Then we'll multiply the -10 into both pieces. So we'll do this. -10 times x is -10x. -10 times -10 is positive 100. We'll combine our like terms. So we have x squared -10x plus -10x is -20x. And then we have that plus 100. X plus 1 squared is x plus 1 times x plus 1. Okay, so we're getting x times, we're going to distribute that x in. So this first part, x times x is x squared. X times 1 is 1x. Then distribute the 1 in. 1 times x is 1x, and 1 times 1 is 1. Combine your like terms. So we get x squared, and then we have 1x plus 1x, and we get 2x, and then we have that plus 1. So look at the results here, okay? And each of those expressions is called a perfect square trinomial. Okay, why do you think it's called a perfect square trinomial? So perfect square, I mean, it came from squaring something. It came from multiplying a binomial times itself, a term times itself. So it's the exact same factor multiplied. Trinomial is because we have 3 terms. Okay, so the perfect square trinomial, we multiplied something times itself. And the result that we got, okay, was a perfect square trinomial. So this thing came from multiplying 2 binomials together, the exact same number together. And then do you notice anything about the middle number and the last term? Okay, did you notice any patterns that happened here? So each time we kind of had this 7 that was in here, that times that squared gave us the last number, and that number times itself twice gave us this middle number. So this 10 times 10 gave us the 100, -10 twice gave us the -20. 4 times 4 giving us 16. Positive 4 and positive 4 is giving us that 8. 1 squared is 1. 2 ones is 2. Okay, or this one that I just randomly did down here. 2 squared is 4. 2 negative 2's gives us -4. So let's take a look at this. Which of these expressions are perfect square trinomials? Which ones follow this pattern that we just talked about? See if you can come up with it. And then any that you decided are perfect square trinomials, see if you can write them as the binomial squared. So you can kind of look at this either way. It depends. Do you like to look at the middle term to decide what this should be? So this negative 14 divided by 2 is that negative 7. And then negative 7 squared is 49. You could do that way. You could also look at the 49, square root it, and then double it. So it kind of depends on which way you like looking at it. So let's look at these a couple ways. So this 9, okay, would have to be a number squared. Well, 9 is 3 squared. And then 2 of those for the middle, we could do 2 negative 3s because 9 is 3 squared or negative 3 squared. And then 2 of those would give us that negative 6. So if we also then rewrite this, so this is a perfect square trinomial. So we can work on rewriting this. So this would be x minus 3 squared because negative 3 squared is positive 9 and negative 3 times 2 is the negative 6. So let's look at this one starting in the middle. So half of 10 is 5. Is 5 squared 20? Okay, so 5 squared equals 25, not 20. So this one is not a perfect square trinomial. 18. Okay, half of 18 is 9. Is 9 squared 81? Yes, it is. So this is a perfect square trinomial. Okay, so we wanted, this is a positive 9 because 18 divided by 2 is positive 9. So this is going to be an x plus 9 squared to give us the two 9x's in the middle to get 18x, and then the 9 times 9 to give us the 81. Okay, so negative 2 divided by 2 equals negative 1. Okay, is negative 1 squared the positive 1? And it is. So if we write it as a perfect square binomial or as a squared binomial, that negative 1, okay, is going to be your term inside there. So 2 negative 1x's gives us that negative 2x in the middle. And then the 1 times 1 gives us the 1. Final one here. Okay, and you could look at this backwards again. So you could look at what squared gives us 16. So this is 4 squared or negative 4 squared. And do two 4s give us 4 in the middle? No. Okay, and you could also look at it again from looking at the middle term first and dividing by 2. Okay, so divide this by 2, that gives us 2. And 2 squared, is that 16? And no. So that's not going to give us the correct binomial here. All right, then let's take a look here at the equation for a circle that we looked at in a previous lesson. So what is the center of this circle? So write down the center and the radius from this equation. So remember the center is you do x minus the x coordinate. So x minus 2. So the x coordinate is a 2. And then y minus the y coordinate. Well, this says plus. So this was a negative 7 in order to flip that to a plus. So we would have had to done y minus a negative 7. So that would be our y coordinate of the center. And then the radius is 10. So let's go ahead and apply the distributive property to this, okay, which means let's actually multiply out each of these perfect square components. Okay, so let's multiply this part out and let's multiply this part out. So follow it, like you can absolutely go over and just multiply these out, distributing the x into both. So x times x is x squared, x times -2 is -2x, -2 times x is -2x, -2 times -2 is +4. And then combining like terms here in the middle. So we have -2x and -2x is -4x. And then a 4 at the end. So that's going to be this portion of the equation. So we get x squared minus 4x plus 4. Then we want to multiply out the y part. Okay, so you can do it this way, absolutely, where you put y plus 7 times y plus 7. You can also try to use that pattern that you just saw. So we know we're going to get y times y, so we're going to get a y squared. Then we also know we're going to get a middle term that is 2 of these. Okay, just like this. See, 2 of these? So we're going to get 2 7y's here. So this is going to be 14y in the middle. And then the last term is going to be that 7 squared. So you can certainly try to just use your pattern as well. And then 10 squared is 100. Now, if you still don't see the pattern fully, then keep multiplying these out. So do y times y is y squared. Y times 7 is 7y. Then distribute the 7 to both. So 7 times y is 7y. 7 times 7 is 49. And then combine those middle terms, 7y plus 7y. And then you have that 49. That will get you this part. So if you don't see the full pattern yet, keep multiplying it out until you do. So now we want to rearrange the terms so that one of the sides is 0. So we're going to bring this 100, okay, over to this side. So one thing we can do is put these two terms together because they're both constants. So we can just leave the x squared minus 4x, the y squared plus 14y, and then we can combine these together, 4 plus 49. Okay, so we actually have a total of 53 there, equals 100. And now we want to get this 100 off of this side. So what I'm going to do is subtract 100, because 100 minus 100 is 0. And if I do it to one side of the equation, I have to do it to both. And when you're adding and subtracting, you just combine like terms. So when we're subtracting the 100, we're going to subtract it, or we're going to combine it with this 53. So my x squared, my x squared, my minus 4x, my y squared, and my 14y are unchanged. And 53 minus 100 is negative 47. 100 minus 100 is 0. So if we were to kind of rearrange this circle equation by multiplying or expanding it out and bringing the 100 over, it would look like this. So this and this are equivalent to each other, okay, meaning they represent the same thing. So let me just write it down here next to it. So these two equations are the exact same thing. So this equation looks a little bit different, but also represents a circle. So this is the expanded form, kind of. This is like right here, like this part. Okay, before we brought the 100 over, we're seeing this. So how could we rewrite this equation to find the center and the radius? So basically we want it to look like this. Okay, so we want to say, all right, it's easier to find the center when it's written in perfect square binomial form. So when we have these written out as binomials squared. So could we do that? Do we see some perfect square trinomials in there that we could work backwards with? So right here, when we're comparing these x's with this 9, do we see that the pattern fits that this term divided by 2 is 3, squared is 9. So we could factor this part back to x plus 3 squared. And then is this y part follow the pattern? Okay, so this middle term, if we divide negative 10 by 2, that's negative 5. Is negative 5 squared 25? And it is. So y minus 5 squared will be the factored version of that. And then equals, now remember this is r squared. So here's r squared. So this is our r squared. So what number squared gives us 64? Okay, so thinking of squaring backwards would be square rooting if you're not sure. If you don't know what number it is, that's how you could type it in your calculator. So square root of 64 is 8. So 64 is, let me write it in green here. 64 is 8 squared. Okay, so we've just kind of rewritten these terms. So now what is the center? Okay, so the center, x minus the h coordinate. So the h coordinate here is negative 3. Because remember, it was minus here, so minus a minus would give us a plus. What's the y coordinate? So what number did we subtract from the y here is 5. And then our radius is 8. All right, so if we rearrange the problem, okay, so the one we just looked at, if we rearrange it to get this 64 to the other side. So remember, one way we could manipulate this equation in a different way is to combine these numbers. They're both on the same side. Okay, so this side gives us an x squared plus a 6x plus y squared minus 10y. And if I add together these constants, 9 plus 25, I get 34. Okay, equals 64. So just combined like terms on the left side. Then I could subtract 64 from both sides. And when I combine that with the like terms, I still have that x squared plus 6x plus y squared minus 10y. And when I simplify 34 minus 64, I get negative 30. 64 minus 64 is 0. So there's multiple different ways to write an equation that represents a circle. So we could have this one, okay, which is right here. We can have the one from the last screen where we actually factored it back to the binomials squared, so it's easy to find the center and radius. We could also pull this 64 over, okay, which is this one right here. So all of these are the exact same equation, just written in different ways. So on the next slide, you're going to get 4 equations of a circle. I want you to find the center and the radius of each, and then I want you to rank them on which one you thought was easiest, which one you thought was hardest, okay, and then in between, so 1 through 4. So take a look at these. These are all equations of circles. Find the center and the radius of each, and then rank them. So you can pause the video and try that, then come back. So whether you think these are hardest or easiest will be relative to you, kind of just depends on how you're looking at it. But remember that the equation for a circle kind of looks like this. It starts like this, right? And that seems to be a pretty easy way to find the center and the radius when it's written like this. So we see that happening in this one where we've got that minus 23 in here. Okay, you've got this 18 here, and then we've got the 60. So this one looks like it's written out pretty much like this. So center would be 23, negative 18, since this is a plus. So negative 18, and then the radius squared. So they're giving you the radius at 60. This one is written pretty similar to that. Okay, it's just if you recognize that x is the same as x minus 0, and that y is the same as y minus 0. Okay, and that 1 is 1 squared. So this one's giving you a center of 0, 0, and a radius of 1. Okay, these next ones you'd have to kind of manipulate a bit. Okay, so we'd have to recognize the perfect square binomial here of negative 18 divided by 2 is negative 9, and negative 9 squared is 81. So we can rewrite this part as x minus 9 squared. This one, negative 16 divided by 2 is negative 4, or sorry, is negative 8 divided by 2. Okay, is negative 8, and negative 8 squared is 64, so that part can be rewritten. And then 4 is 2 squared. So then we can see the center is 9, 8. Okay, so x minus 9, y minus 8, so 9, 8. And the radius is 2. Okay, this one, we don't really have a constant here. So we have 20 divided by 2 is 10, but we don't see the 100 here that we need. So if this is x plus 10, there needs to be a 100 here. And this is negative 24 divided by 2. So this one's appearing that it should be y minus 12. But 12 squared is 144. So we should have a 144 here. We do have this 243. Okay, so we could kind of split this. Okay, but that's our we need 100 of it for this one and 144 for this one. That totals 244. Okay, so we actually need 244 here. So we have a deficit of 1. Which then if we bring the 1 to the other side, the negative 1, okay, puts a positive 1 over here, which we're going to get into more, but that is kind of looking at that one. That one's quite a bit more difficult, and you maybe haven't done anything like that. To get a center of negative 10, 12, okay, and then a radius of 1. This part might be pretty confusing. Like, what is happening here? And that's okay. You didn't need to be able to come up with that. Okay, so ranking them how you want. My rank is that this one was pretty easy. Actually, to me, this one's easier because I know this. So you just know 0, 0, 1. Okay, so this one's easiest to me, then this one, probably then this one next, and then here. Up to you how you decided. All right, so summary for this lesson. So we took a look at kind of rewriting our circle equation a bit differently by actually multiplying out these square binomials. And so what we noticed in these binomials squared is that this last term, we had it twice for the middle. Okay, so we had 2 6x's for the middle, and we had it times itself, or squared 6 times 6 for the final term. So we had 2 negative 8s for the middle, and we squared it for the end term, 8 times 8. So 2 5s gives us 10 for the middle term when we add them, and the final term will be 5 times 5. So there's that pattern there, okay, that we're trying to look at and notice. So each expression on the right, so these are called perfect square trinomials because they're the result of taking the exact same binomial, 2 terms, times itself. And we get this pattern that you've got, okay, the x squared when the x squared is a 1. Then the center term is the square of half the coefficient. Okay, so half of this, so half of 10 squared. is what this is saying. Half of that middle term squared. So in this one, half of negative 14 is negative 7, squared is 49. That's going to help us in circles because if we see this stuff expanded, we'll be able to go backwards, okay, so that we're able to see the center easier if we can recognize this pattern. So if we can recognize that negative 22 divided by 2 is negative 11, squared is 121, okay, we can get to this. Whoops, not to that. We can get to this. And if we recognize that 2 divided by 2 is 1 and 1 squared is 1, we can get to this, which helps us with that center. So recognizing that pattern and applying it. So hopefully you're able to calculate and interpret trinomials in expanded form, which is the multiplied out form, and then factored form, okay, which is the binomial squared form. Okay, so here's the factored form. The expanded form is x squared minus 6x plus 9. So here's expanded and here's factored. Here's a cool down for you to try to see if you can rewrite this in the circle equation form to determine the center and the radius of the circle. And if you are struggling, be sure to reach out to your teacher.